Hello, Latin geometry students. In this assignment, we're going to continue practicing trigonometry, but in this case, we're going to talk about the types of little tricks that come up when doing a basic trigonometry problem. We should already know how to do these kind of problems where we have a right triangle and we're going to do some basic SOHCAHTOA to find a missing measurement for a missing side. But today, we're going to talk about some of the other kind of things that come up. Things like, hey, what if we know both of the angles in the triangle? What do we do if we know two angles? What do we do if we know two of the sides in the triangle? In both those cases, you're just getting some extra information. What happens if x is on the bottom of a fraction? And what if you got to find a whole bunch of things in the triangle, what we call solving the triangle? Okay, not a big deal. All of these problems have really simple solutions. None of these are going to be all that tricky, but you got to know what to do when you run into these problems. So let's start with the first one. This problem's a little bit different from the types of problems that you've been doing so far. And the thing that makes it different is that in this case, you know two of the angles. We got the 40 degrees and the 50 degrees. The problem's still going to be done the same way. We're going to identify OA and H, pick sine, cosine, or tangent, and solve it. The problem is the first step. The first thing we're supposed to do is pick an angle. Which angle should I pick? Well, it doesn't matter. Just pick one. It doesn't matter which angle you go for. You'll get the same answer whether you pick the 40 or the 50. For example, let's say we're going to pick the 40 degrees. If we do that, then step 2 is to label our sides O, A, and H. We don't care about this blank side over here, so we just got the x is the adjacent, 36 is the hypotenuse. A and H, we come up here and figure out which trig function, sine, cosine, or tangent. We'll use A and H, and it's going to be cosine. Then once we know that, we're going to plug our numbers into the equation. X goes in for the adjacent side, 40 goes in for our angle, 36 goes in for the hypotenuse, so we have this equation. And then all we got to do, multiply both sides by 36. And we're going to end up getting 27.6 for our answer. But what if instead we had picked the 50 degrees? All right, that changes a few things. For example, x is no longer our adjacent side. Now x is the opposite. And 36 is still the hypotenuse. Now we have a different angle, and x is no longer the adjacent, it's the opposite. But if we follow the same steps, it should be okay. Opposite and hypotenuse is going to be the sine. So we're going to start with our sine. Then we're going to plug in the x, the 36, and the 50 into our equation. We'll have sine of 50 is equal to x over 36. And then we solve this equation by multiplying both sides by 36. And we still get 27.6. So if you're given more than just the one angle in a problem, you can just pick whichever one you think will make the problem easier for yourself. And that works because the whole system of trigonometry is set up to work really nicely. It's got a good little system. See, these two things are the same. Cosine of 40 is x over 36, and sine of 50 is x over 36. This always happens in a right triangle. One angle's sine is going to be equal to the other angle's cosine, and vice versa. If whatever happens to be the sine of one of the acute angles will be the cosine of the other acute angle. So it always seems to work out. Okay, the second type of weird problem looks like this. And what makes this one different from the ones you've seen is normally we have an angle, which we have. We have an x for one of the sides. We got that. And then we know one of the other sides. But in this case, we know two of the other sides. Oh, no. Which one should I use? How do I do this? Well, just like when you know extra information about the angles, which one should you use? Doesn't matter. Just pick one. Whatever one you think is going to make your problem easier. For example, we go through the steps the normal way. We start by picking our angle, 37. And then label our sides. We get the opposite, adjacent, and hypotenuse. Okay, so if we want to start by using the opposite and the 30, x and the 30, this would be opposite and hypotenuse will be sine. So if we use these two, we're going to have the sine of our angle is equal to the opposite over hypotenuse. That becomes the sine of 37 is equal to x over 30. And then we simply solve this problem the way we've solved all the other ones. We're going to end up getting 18.1. But what if instead we wanted to use the 24, the adjacent side? No problem. We're still using the 37. We still got x as our opposite, but now we are on opposite and adjacent. That's going to be tangent. So we'd say the tangent of our angle is opposite over adjacent. Plug in the x, the 24, and the 37, and then solve for x by multiplying both sides by 24. We end up getting the same answer. So if you're given an extra side in a problem, you still just solve it the same way. You just pick which side you want to use. Sometimes picking one side or another might make the problem a tiny bit easier or harder, but it's not going to be a big difference when you do it, and you should end up with the same answer either way. Now, this problem. This one might look exactly like the problems we have done in the past, but there is something slightly different. If we start this problem, we're going to use the 62 degrees for our angle. We have the adjacent and the hypotenuse already marked. when we set up our equation, something different is going to happen. What you've gotten used to is always just putting x in the same place, but x doesn't have to be in the same place. See, for the adjacent and hypotenuse, a and h, that's going to be a cosine problem. The angle is still going to go in here for the 62, but a is now the 14, and x is the hypotenuse. That's now in the bottom of the fraction, and that's what's different about this problem. X is on the bottom of the fraction. Why was it on the bottom instead of the top? It's always on the top. No, we've only just given you problems where it was on the top. But if x is the hypotenuse, it's going to end up in the bottom. Or if you're doing tangent and it's the adjacent side, it's going to end up on the bottom of the fraction. Now you might think, okay, so I still solve this the same way, right? I just multiply both sides by 14. No, you do not. You cannot multiply both sides by 14. You can't solve this problem the same way as the other ones. Why? Well, now remember, this is because x is in the bottom, but let's make a simpler problem, one that you could have done in grade school with x in the bottom of a fraction, and see how it's actually different. Here, let's start with an easy problem that everybody knows. 2 times 5 is equal to 10. That means that 10 divided by 5 is equal to 2, right? 10 divided by 5 equals 2, and 10 divided by 2 is equal to 5. All right, so we know this is supposed to be 2, but let's pretend we didn't know this 2 over here. Now let's say it was an x. If you had to solve this problem, you would not multiply both sides by 10. That's not going to work. Then you're going to end up getting 50, and that's not the answer. We know the answer is supposed to be 2. What you can do is notice this. 10 divided by 5 is 2, means the same thing as 10 divided by 2 is 5. This is what in grade school they may have called a fact family, but these two numbers are interchangeable. In other words, I can switch these two numbers, and it's still true. We can make it, instead of 10 divided by 2 is 5, 10 divided by 5 is 2, and we can move the x. Wait a minute, what? All right, let's try this again. Another fact family, 2 times 3 is 6. That means that 6 divided by 2 is equal to 3. Think about that for a second. You should be like, yep, I already know that. Now, what you may not realize is you can swap two of these numbers. These two numbers are interchangeable. You could rewrite this as 6 divided by 3 is equal to 2, and it is still true. You could swap the number on the bottom of the fraction for the number on the other side. So when we had this problem just a few moments ago, 14 divided by x is equal to the cosine of 62, you don't multiply by 14, you swap the x with the cosine of 62. So this problem where we had this, cosine of 62 is equal to 14 over x, what we really want to do is say x is equal to 14 divided by cosine 62. And we just put that in our calculators, 14 divided by cosine of 62, and we get about 29.8. Here's another problem that's just like this. We're going to end up with x in the bottom of the fraction. I want you to try to solve this thing and figure out what to do with x in the bottom. Okay, so step 1 in this problem, we're going to pick our angle. We're going to go with the 28, label our sides, the O, A, and H. We're not using A, it's just O and H, so that's going to be a sine. We plug our numbers 54, 28, and x into this equation in the right spots. And we have sine of 28 is equal to 54 over x. Then swap them. X is equal to 54 divided by the sine of 28. And the rest of this is just plugging that bad boy into a calculator. You should get about 115. Okay, the last kind of tricky problem that we run into is when you're asked to find more than one thing. We frequently call this solving the triangle because we're going to find all the missing parts, the missing angle and 2 missing sides. All right, so should we find this side first? Should we find this angle first? Should we find this side first? And the answer is, it doesn't matter. You can find any of them in any order you want. You can do these in any order. Usually I just go with the easiest thing, and it's almost always easiest to find the angle first. So I'm going to find angle Z. How do we find the missing angle? Easy. Just make sure the 3 angles in the triangle add up to 180. 65, 90, and Z are the 3 angles in the triangle. So these 3 angles have to add to 180. All we have to do is combine like terms and solve for x to find Z. In this case, we're going to get 155 plus Z is 180, and eventually Z is just 25. So we've got Z. Next, we got to figure out x or y. Which one? Doesn't matter. Pick one. And for me, I'm going to pick x first. Why? I don't know, alphabetical or something. So if we're going to find this, we're going to start off the problem the way we normally do. Pick our angle. It's going to be the 65. You could use the 25, but the problem with using a number that you figured out is if you made a mistake early, it'll mess up everything that comes after it. So I'm going to try to keep using the numbers that are given to me in the question. From the 65, we identify our sides, opposite, adjacent, and hypotenuse. Now, if we want to find x, we can use x and y. Well, that'll leave us with two unknowns, so we have to use the 28 down here. So we're going to have to, in order to find x, use the opposite and adjacent side. O and A, that's going to be tangent. So we're going to say the tangent of our angle, 65, is equal to the opposite over adjacent, x over 28. And then simply solve this equation the way we've been solving them. We multiply both sides by 28, and we'll get x is about 60. Last off, finding y. Okay, now, which other side should I use with this? We have the hypotenuse. Should we use the opposite or the adjacent? Well, you could use either answer. We know the opposite is about 60, but the word about is the problem there. We rounded a little bit to get here. And if I made a mistake on finding x, that'll throw off my answer for y. So again, I'm going to rather use the 28. So we want to use the adjacent in hypotenuse. That's cosine. So we can say the cosine of our angle, cosine of 65, is the adjacent, 28, over the hypotenuse, y. And here we end up with y in the bottom of a fraction. No problem. You should know how to solve that. We simply swap those. Y is equal to the 28 divided by the cosine of 65. And we're going to end up getting about 66.3.